Welcome to our explainer. If you're watching this, you're probably the one responsible for keeping systems online. And, keeping things running usually means dealing with a whole lot of alerts. Well, today, we're going to walk through the ultimate guide to building smart alerts using Grafana Unified Alerting. We're going to take your alerting strategy from a massive source of stress and turn it into a highly tuned, actually actionable system.
So let me ask you a question, and be honest with me here. Does every single alert that pings your phone feel like an absolute fire drill? If you're constantly jumping at shadows, reacting to these brief CPU spikes or momentary network blips that literally resolve themselves 5 seconds later, well, you've got a classic alert fatigue problem.
I think we can all deeply empathize with this anonymous quote, "Another transient spike, I'm exhausted," right? When an engineer is jolted awake at 3 a.m. for an issue that magically fixed itself by the time they even open their laptop, trust in the whole monitoring system just breaks down completely. Poorly designed alerts generate noise, and when an alert fires constantly and just gets ignored, you are in a really dangerous position. Because honestly, an ignored alert is worse than having no alert at all.
Okay, here is our run book for today's explainer. We're going to diagnose the alert fatigue problem, cover the basics of unified alerting, actually build a smart alert together, tackle a real-world payment error scenario, and then finally lock down our scheduled maintenance with silences. Let's dive right in.
Starting off with Section 1, the alert fatigue problem.
So let's look at the difference between what most teams do and what they absolutely should be doing. On one hand, we have a noisy threshold alert. This thing is configured to page you instantly the very second a metro crosses a line. It is way too sensitive to transient failures, those annoying, short-lived spikes that auto-resolve before you can even blink. But on the other hand, we have a smart alert. A smart alert actually uses multi-condition rules and pending periods. It evaluates data over a time window and aggregates it to smooth out those short spikes. It basically requires an issue to persist before it even thinks about waking you up.
Now, to build that smart alert, we need to understand our tools. Moving to Section 2, Unified Alerting Basics. Grafana's Unified Alerting consolidates everything into a single engine. The first key concept here is the evaluation group. This is a setting that defines how often related rules are evaluated together. Notice how Grafana optimizes performance behind the scenes here? Instead of firing off thousands of queries completely randomly, it groups related alerts together, like say all your API alerts, and evaluates them at the exact same interval, maybe every 1 minute. It keeps your query engine running super efficiently.
Once evaluated, your alert enters a specific state cycle. Let's step through it. First up is normal. Everything is perfectly healthy. But if your threshold gets crossed, it doesn't immediately fire. Instead, it moves to pending. It waits here to see if the condition is actually met for a specific duration. If the issue really does persist, then it transitions to firing. And boom, notifications go out. Finally, there's a no data or error state, which just lets you know if the query itself failed or came back empty. This cycle right here is the absolute heartbeat of smart alerting.
And that brings us to the pending period. This is literally your magic sword against flapping alerts. By configuring a forward duration, you're essentially telling Grafana, hey, do not page me unless this CPU spike or error rate stays high for at least 5 minutes. This single, simple setting will eliminate almost all of your transient noise. It's a real game changer.
Okay, theory time is over. Let's get our hands dirty with Section 3, building a smart alert. And by the way, you can totally follow along with these concepts using Grafana's demo environment over at play.grafana.org.
When you open up the condition builder in Grafana, you're going to follow 3 methodical steps. Step 1, you query your data stores, fetching all that raw time series data. Step 2, you use a reduce expression. This step is absolutely vital. It takes that complex data and aggregates it, say grabbing the mean or average value over your time window, which effectively smooths out all those annoying spikes. And step 3, you just set your threshold condition against that newly reduced value. Simple, right?
Let's put this into practice. Section 4, Scenario, Payment Error Spikes. Imagine we're running an e-commerce platform. We need to know instantly if our payment gateway fails, but we definitely do not want to be paged just because a single user typed their credit card number in wrong. So we decide to set our threshold at greater than 5%. We aren't looking at raw error counts here. We are looking at a percentage of total traffic. Remember, alerts should primarily detect user-facing failures, not just internal component hiccups. A 5% failure rate on payments? Yeah, that's a definite noticeable user symptom.
Next up, we set our pending period to exactly 3 minutes. This is what makes it a truly smart alert. That payment error rate has to stay consistently above 5% for 3 consecutive minutes. If there's just a quick 30-second network hiccup with the bank's API that auto-resolves itself, the alert just sits in pending, drops back to normal, and you get to sleep right through it. But if it lasts those full 3 minutes, you know for sure you have a real outage on your hands.
So let's say the alert is firing. Where does it go? This is where contact point routing comes in. We use labels to route this specific alert. We've tagged it with the label service equals payment. Our routing tree sees that label, matches it up, and shoots it straight to our target, a Slack webhook that's securely connected directly to the critical errors destination channel.
And then, right there in your Slack channel, you get this beautiful, clean, actionable notification. It tells you exactly what's wrong, a high payment error rate, and that it's been active for 3 minutes. Implicitly, because of all the smart rules we just built, you know this is absolutely not a false positive. Action is required immediately. You know it's actually time to open your laptop.
But hey, what happens when you actually plan to take the payment gateway offline? Maybe for a scheduled database upgrade. Let's move to Section 5, Scheduled Maintenance and Silences. Because alert fatigue doesn't just come from bad thresholds, a lot of it comes from alerts firing during known expected downtime.
To handle this gracefully, we use a silence. Now, the critical word you need to focus on here is suppresses. A silence is a temporary configuration that suppresses notifications for matched alerts, but, and this is key, without interrupting the actual rule evaluation. The monitoring continues internally, the alert state still changes to firing in the background, but the silence just intercepts the notification. Your Slack channel stays perfectly quiet, but your data history remains completely intact.
Let's map out exactly how this looks on a timeline. Say 10 minutes before the work starts, you create a silence with your ticket ID for auditability. Then, at minute 0, maintenance begins. The system goes offline, and your alerts evaluate and trigger internally, but they remain totally muted. And here's the absolute best part. At minute 60, the silence automatically expires. You don't even have to remember to turn your alerts back on. That is a massive win for reliability. So, we've covered the power of evaluation groups, pending periods, label-based routing, and silences. You now literally have the blueprint to restore peace to your on-call rotations. So I'll leave you with this provocative thought as we wrap up our explainer. Go look at your dashboard right now. Which noisy flapping alert are you going to rewrite first? Dive in, tweak those pending periods, and make your alerts work for you, not against you.